Okay, so I'm going to be solving an ERO in 3D, and I'm going to start off with three equations, sum of the forces and sum of the moments. So there's a negative 55 force right here in the negative x direction, negative 55. There's two x forces at E and F, so I'm going to set both of those to positive, and we'll find out the direction later. And I believe there's only three x forces, so we'll move on to the y. There is a y force at F and a negative y force here in this cable DG. So we would need to find the unit vector for that, which I have down here. Okay, so it's a negative y force, so minus 0.4, that's a 47 dg, and I got that from right here. That's the unit vector. And I believe those are the only two y forces, so we'll move on to the z. We have a z force at E and F. We have a negative z force in that cable. And I think that's it, so we'll move on to the moments. We'll start off with this 55-pound force. If we move it down to this axis right here, like that, it will create a positive moment about the z-axis, and that's going to be 550. Because the distance between them is 10 inches, so 55 pounds times 10 inches, and the units are going to be pound inches. If we move that force from there to the origin, we're going to get a negative, or a moment about the y-axis that's negative, and it's going to be 55 times 9.6, which is 528 pound inches. So we should be done with that force now, and we'll move on to this bearing at E. We're going to have an x force right there. If we translate that to the origin, it's going to create a negative moment about the z-axis, so we're going to subtract 7.6 inches is the distance times EX. And we could do the same thing with this x force at F, minus 2.4 inches is the distance, times Fx. And then we're going to have a z force at both of these, so it's going to, if we translate that, it's going to create a positive moment about the x-axis. So it's going to be EZ times 7.6 is the distance, plus FZ times 2.4, and those should be done with. Oh, we also have a y force in the F, at that bearing at F, but that goes through all the axes, so it does not create a moment. Here we're going to have a negative z force, and that's going to create a positive y moment. So we're going to multiply 0.88 dg times 6.4 is the distance, and then we have a negative y force, which is going to create a negative z moment. So negative 0.47 dg times 6.4, and if we plug that into the calculator, we should get these.